Hello. So in the last video, we set up a fun optimization problem and got an equation and an idea of what we need to do to solve it. So just to recap what we did in the last video, is we determined that if we have a rectangle here that we mean to turn into a box, we need to cut squares of each corner of length x, and we found an equation governing the volume of a box that would be made for that. Now, this is the equation here. This one is the derivative of that equation because we wanted to find the largest volume that could be stored with a box of these dimensions. Now then, to find that, we know from our knowledge of optimization that at a maximum point or minimum point, the slope of our function will be 0. The concept there being that it's transitioning from a low slope to a high slope, or that the double derivative is positive or negative in the transition. Now, these aren't always minimum or maximum points, but usually they, in this scenario, they're going to be. Unless you have a whole bunch of vertices all over the place, we can be at least somewhat sure that this is going to govern our maximum and minimum points for this equation here. Alright, so we need to set this equal to 0, right? Because this is the slope and this needs to be equal to 0. Now, this is a quadratic, obviously, and there are a lot of ways to solve quadratics. Factoring would be very hard in this scenario, so I'm just going to use the quadratic formula, which says that our x values will be equal to the negative b. What's our negative b? That's 300. Our coefficient on the second term, plus or minus, so we get two answers, the square root of b squared, negative 300 squared is the same as 300 squared, which is the same as, oops, let's just straighten this out. Is that right? 90 thousandths? I believe so. Plus 4 AC, A being the coefficient on our first term, and C being our constant. So 4 minus 4, 12 is our A, and C is our 1, 3, 50. Alright. Yep. That should be good. And then we divide by 2 times our A, 12. And I am going to use a calculator to do this, to find our two values, because I don't want to do this arithmetically. Alright. So 90,000 minus 4 times 12 times 1, 3, 50. Then we take the square root of that. Alright. And then let's add 300 first. Add 300. And lastly, divide by 12 times 2 is 24. Alright. We get approximately equal to 19.11. And And then our second answer, as we have two answers, we have plus or minus on the numerator. 300 minus the square root of 90,000 minus 4 times 12 times 1350 divided by 24. And our second is approximately equal to 5.89. These are our two answers. These are the vertices. One is a maximum and one is a minimum. Then we plug these into our equation over here, which is the double derivative. Now, as you may recall, if the double derivative is negative in the same area, we're dealing with a maximum, and if it's positive, we're dealing with a minimum, because if it's a minimum, the slope is increasing and the rate of change of the slope is positive, and the opposite for a maximum point. So let's plug our two values in and see what they come up as. I'm just going to use a calculator again to speed things up. So 19.11 times 24 minus 300. Alright, so for our first value, we get 158.64 approximately. Now this is positive, so we're dealing with a minimum point, right? Minimum point, not maximum point. So this is our minimum point here. Alright, so now let's put the other one in. So this time it's 5.89 times 24 minus 300 and whoa, 5.89 times 24 minus 300, and we get negative 158.64. So this is a maximum point. Alright, so here, then, we know that our maximum point is at, I'm sorry, I circled the wrong one. No, this is the wrong one. I'll just do that. The correct one, which I'll do in green, is this one. This is our max. So at that point, x is when we have our maximum point. And as we know, x is the length of one side of one of these squares. And so, now, if we're making a box with these dimensions and these lengths, we know that to get the maximum volume, we need in x distance for a side of these squares to be 5.89. That's the distance of that little cutout section here, or the height. Thanks for watching. I hope you enjoyed this.